What remains for the Poisson distribution is just the characteristic function and the uh, generating function. And for the characteristic function, you just have here the PMF, this here, and you just have e to the power j omega k multiplied by the PMF and summed up. Again, I can pull out e to the power minus lambda because it doesn't depend on k. And here I have lambda to the power k, and here e to the power j omega to the power k. So that is lambda times e to the power j omega to the power k divided by k factorial. So this here, this, well, along with the sum, of course, is the Taylor series expansion for e to the power lambda times e to the power j omega. Okay? So this here, I had e to the power minus lambda here also. So I can write this as e to the power lambda times e to the power j omega minus 1. So you have an exponential in the exponent of another exponential, but this is the function. And the generating function as related to this characteristic function with such distributions, and we can just replace e to the power j omega with a z and obtain the characteristic function by as e to the power lambda z minus 1. Now I'm going to repeat this one. Um, I am just giving you the generating function by this replacement. Instead of e to the power j omega, I just write z. But this is not general, okay? Be aware of this. This is because, well, the characteristic function is expected value of e to the power j omega x, and the generating function is the expected value of z to the power x. And if you remember, this was defined for distributions where the sample space is 0, 1, 2, etc. Okay, the non-negative integers. And in that case only, you can replace e to the power j omega with a z. And in this Poisson distribution, we have that relationship. So I could have done that, but it's not always the same. Okay, you cannot just write directly replace e to the power j omega in the characteristic function with a z to obtain the generative function for any distribution. That's not a general result. That's what I'm trying to emphasize here, due to the definition of generating function. So next, we will talk about continuous distributions.